So now I just want to address what is the approved prebiotic definition, if you will. And Gibson and Robefroid are some very well-known researchers in the area of prebiotics, and they've been doing published a lot of studies over the past decade. And of course, there was a consensus as well identifying how do we label a prebiotic. So just so you can refer to your slide, you'll see that it is a non-digestible food ingredient, and the key here is that it's going to beneficially affect the host. And it does this by stimulating the growth or, again, the activity of various bacterial species that are already present in the colon, but it's those bacterial species that have a beneficial effect on the host, not a detrimental effect on the host. So ultimately, it's going to improve the health of the individual. So with the next slide, addressing this bifidogenic effect. And the bifidogenic effect is a term that you have possibly read about or may have heard of. If not, I'll introduce it to you. And that's where you use these prebiotics, so specifically fructooligosaccharides and inulin, for example, where they selectively promote the good bacteria. And some of those good bacteria that have been readily researched would include lactobacillus and bifidobacteria. And by increasing the levels of these bacteria, you are lowering the colonic pH because you have a lot more release of lactic acid. And this will actually alter the colonic environment to make it more, or I should say less favorable for the potentially pathogenic bacteria, and again allow the good bacteria to continue to thrive and proliferate. So this in itself is referred to as the bifidogenic or the prebiotic effect. And this is what we would strive for when we're recommending these unique types of soluble fibers to ultimately change the makeup of the intestinal tract, especially within our colon. And one point I'd like to share with you is there was a study by Buddington back in '96, because a question that oftentimes came up is how much of these prebiotic or these unique fibers would an individual need to see this bifidogenic effect. And in the Buddington study, they showed as little as 4 grams a day of these prebiotics showed an increase in bifidobacteria. And in this particular study, they looked at fructooligosaccharides. And again, as little as 4 grams a day. So it doesn't take a lot of these unique prebiotics to see an increase in the level of the good bacteria within our colon. So now I'd like to focus a little bit on these prebiotics specifically. In other words, where do they come from? Where do we get them in our diet? And as I've mentioned the term many times, these short-chain soluble fibers, we can actually become even more descriptive with how we identify these prebiotics. And the classification, if you will, they are referred to as fructans. So when you think about your carbohydrates, for example, obviously you have your monosaccharides and disaccharides, et cetera, oligosaccharides. Well, these fructans are actually fructose polymers, and there are groups of fructose molecules, usually with sucrose added. And basically, you find these naturally occurring in the diet, and I mentioned some of the foods that may contain these particular types of prebiotics. So wheat, artichoke, garlic, tomato, onion, these are some of the foods that you would find naturally occurring prebiotics or these fructans. And as far as the literature, those most commonly researched or what we have available to us as far as the fructans would be inulin or fructooligosaccharides. So again, these are the most widely studied prebiotics at this time. So on the next slide, when we talk about sources of inulin and fructooligosaccharides, not only can we obtain these prebiotics from food sources, but we can actually obtain them from a manufacturing method. And for example, inulin is derived from the chicory root. Literally, it is a tuber where what the manufacturers do is they take these chicory roots and they wash them, dice them, and then they become the semi-refined syrup. And it's purified so that you get the purest of the inulin available. And fructooligosaccharides can be derived from two ways. Fructooligosaccharides can be extracted from inulin using a partial enzymatic hydrolysis method, so basically breaking down the inulin to make FOS, or you can chemically or enzymatically you can synthesize and make FOS from sucrose, because remember, when we think about sucrose, we've got fructose and glucose molecules. So those are the two ways that you can actually obtain fructooligosaccharides. And again, Robefroid, being a very well-known researcher of these two functional food ingredients, has commented that currently what we have available, and based on the data we have, the food components that would exert the best or optimal prebiotic effects are going to be your inulin-type fructans. So your inulin and your FOS are what they consider to be your pure prebiotics. So how do we differentiate inulin from FOS? On the next slide, when we address the benefits of these short and longer chain inulin-derived fructans, this is a slide just to show you the differentiation between the two. So on the left, we talk about the short-chain fructooligosaccharides. So not to be confused, both these FOS and inulin ingredients are classified as short-chain soluble fibers. But then you break it down a step further and you compare FOS to inulin. FOS is going to be even shorter. And you'll see on the slide that it says DP 2 to 8. The DP stands for degree of polymerization, and that basically means chain length. So your FOS is roughly going to be between 2 and 8 chain lengths of fructose molecules, usually with a terminal glucose molecule. So it's a very simple chemical structure if you think about it. And it's going to be obviously a shorter chain length, and it actually is going to be fermented more quickly compared to the inulin, which is a little bit longer in chain length. And the interesting thing here is when we look at fructooligosaccharides, because they have a faster fermentation process, when they are hydrolyzed or fermented by the bacteria within the colon, because of this faster fermentation process, they tend to support the growth of the bifido or the good bacteria in the more proximal area of the colon. But when we switch gears and look at inulin, again, a chain length or DP of anywhere from 2 to 60, you can see that it's a longer chain of fructose molecules. So it's actually going to take a little bit longer for that fermentation process to take place. So it's actually going to travel farther, typically throughout the colon, to support more of the distal area of the colon, where it actually is then broken down by the existing bacteria. So one of the advantages of combining, say, an FOS and inulin is that it can help to support or maximize the entire area of the colon, so support not only the distal colon but also the proximal colon, if you could combine these two prebiotics to increase or maximize the surface area. But that's the key difference between FOS and inulin. They're both prebiotics. They both support the growth of good bacteria. It's just that one is a shorter chain of fructose molecules. Inulin's going to be a longer chain of fructose molecules.